In this lesson of 10.2, we're going to continue with circles, and we're going to start to talk about arcs. Again, like I said in the last one, we have a lot of vocabulary words here. I suggest you look it up in the glossary and you get them all down and get familiar with them. It'll make it a lot easier if you do that even before watching even the rest of this. So first thing that we have, we're going to be doing arcs. Arcs are whenever we are talking about the outside of the circle. Okay, so this red portion that they have here between A and B, this short little rounded segment, that's what we call an arc. Okay, there's some different things we will look at with arcs. We'll look at their degree measures, and we'll look at how to measure them eventually, how long they are. But so right now what we're talking about is just finding their measure. And the key part of this first is if we talk about a central angle. And so central angle is when the vertex of that angle is the center of the circle. And so as it says up here, ACB is a central angle of the circle C. And so then we have different classifications, just like in angles, how we can just classify something as a right angle, a obtuse angle, straight angle, all that different stuff. When we have arcs, if the measure of that central angle creating that arc is less than 180, then we call it minor. If it is greater than 180, then we call it major, and then if it's exactly 180, then we call it a semicircle, okay, because that's exactly 180, we're cutting that circle in half, so we have a semicircle. So basically, like I said, we're going to be talking about measurements of arcs, and so first when we start off measuring an arc or a minor arc, we can measure that arc by the central angle. So if we know the central angle creating that arc, then they're going to be equal to each other. And notice that we also measure arcs in degrees. So this says the measure of arc AB is equal to 50 degrees. And it's going to be the same as that central angle, which was also 50 degrees. Now if we're talking about the major arc, so say we're talking about ADB. ADB is going to be that 360 minus the 50 of that minor little central angle there. And so that leaves us a measure of 310 if we do the major. Okay, it's important to know that minor arcs, we can name them by just 2 points, okay, because it's easy to identify AB. We just do the shortest of AB. But if we want to do the major arc, we have to name it by all 3 points. Otherwise, when I say AB, I'm going to automatically think just between A and B here. Okay, but this one, the major arc, I want to go the other direction around it. So that's why we say ADB, so that way we go through D and go all the way around to get the major arc. So as we look at this first example, it just wants us to find the measure of each arc. So RS first. So RS, obviously, since it's only 2 letters, that means it's going to be a minor arc. So if we look at it, RS is right here. We have the central angle of RS, so that means I can just put that on the outside as well. And so the measure of RS, measure of arc RS, is also equal to 110 degrees. Now if we look at B, the RTS, RTS is going all the way around through T to S. Okay, so that's everything except for the 110. So that means when I'm trying to find the measure of RTS, I'm going to do 360 minus that part that we're not using of it, 110. And so that means it's going to be 250 degrees. Then the last one it tells us to find is RST. So if I go RST all the way through there, notice that R and T, that line going across that segment, is a straight line. It goes through the center. So the degree measure of a line, we know, is 180 degrees. So if that angle there is 180, that means we send it out, and so that's 180 degrees as well. So the measure of RST is equal to 180, which means that RST is a semicircle. Okay, and it tells us that RT in this in the problem, it told us that it was the diameter. Then if we look at RS, RS is what we called a minor arc. And then RTS would have been major, right? Because it's greater than 180. Then we have another postulate, arc addition postulate. Notice that this is in the same format of some other ones we've seen. We've seen segment addition, we've seen angle addition postulate. So arc addition postulate works the same way. If I add my parts, okay, I add two arcs that are next to each other, it'll give me the whole arc, the big arc that they form. Okay, and so it just has this formula. We can always create it by, again, the whole is always equal to the parts added together. So when we look at this problem, it says GE is the first arc at once. So the measure of GE is going to be equal to the two parts added up. Well, GE is this whole portion. So that means we would add the measure of GH plus the measure of HE. Okay, we would add the parts to get our whole. So if I add those up, GH is 40, HE is 80. 40 plus 80 gives me 120 degrees. So the measure of GE would be equal to 120. Okay, so then moving on to the next one, measure of GEF. Okay, so G all the way through E, all the way through F. Okay, well, we can break it up again into two different sections. First, we can do GE, the one we just found, so the measure of GE plus the measure of EF. Okay, and notice I'm getting these parts. GE, the first two letters, GE. EF, the second two letters, EF. Okay, if you're confused at where I'm getting the parts of it, that's just the way I'm splitting it up. I know all these parts now, so I can plug them in. GE we just found, so I'm going to put in 120. EF it says is 110 because I can put it on the outside for that arc, so that's 110. So if I add them up, I get 230 degrees. So the measure of GEF, arc GEF, is 230. And then our last one of GF. GF is the only one that we don't have any information on, okay? But I can just subtract what the other part. I already know the rest of it. GF is this part, but all the red is the rest of the circle. So if I just do, if I subtract the parts that I know from 360, okay, that whole GEF, then it leaves me with my leftover part. So 360 minus my 230 will give me 130 degrees. So the measure of GF is 130. So if you look at this, always make sure that you know how to do minor and major arcs. So minor is anything less than 130, less than 180. So when I look at it, this one over here is going to be minor because it's less than 180, it's at 130. And this one would be minor as well. If it's greater than 180, then it's major. So this one would be a major arc. This example of example 3, it works a lot just like the ones we've already done. Just so for the sake of time, I'm going to move on. But if you work this problem and you need help, I'm more than happy to help you in class. So this next theorem, we have a couple more theorems before we're finished. Congruent circles theorem. It just tells us that if we have two circles, they're congruent only if they have the same radius, right? Because if they have a different radius, then that means those circles are going to be different sizes. One's going to be a lot bigger, one's going to be a lot smaller. But if their radiuses are equal, then those circles are going to be equal. And then we have congruent central angles theorem. It just tells us that we have arcs that are congruent if and only if they are on either their measures are the same on the same circle or their measures are the same on congruent circles. And so we'll see this in the next example. So it says to tell whether or not the red arcs are congruent in each situation. So in A, okay, we have central angles of 80 degrees here, so I'm going to put it out on the outside of the circle. So CD, arc CD, the measure of CD, is going to be equal to 80 degrees. This one I move it out as well, so the measure of EF is equal to 80 degrees. And so they have the same exact measures, but they are only congruent if they are equal measures and they're on either the same circle or congruent circles. Well, these two arcs are on the same circle, so that means that they are going to be congruent with each other. So I can say arc CD is congruent with arc EF. Okay. In example B, okay, we have this 90-degree angle here, so that means this one would be 90 degrees. And so would, going all the way out to the outside, this one's going to be 90 degrees. So I have the measure of RS is going to be 90. The measure of TU, arc TU, is going to be 90. But are the arcs congruent? Okay. In this case, no. Okay, they're not going to be congruent. So RS, I'm going to say, is not congruent. I'm putting a line through it with TU. The reason for is because they're not the same circle. Okay, they're not the exact same circle, and they're different sized circles. One is smaller, one's bigger. So while their measures are the same, those arcs are not exactly the same. If I move RS and put it over TU, they're not the exact same arc. TU is a lot longer. And then our last one, C, we have this 95, so I'm going to move it out. The outside, the measure of that arc is 95. This one as well, the measure of that arc is 95. So the measure of UV is 95 degrees. The measure of YZ is 95 degrees. And then these two, if you notice the radius, they both have one line on them. So that means that the radius is the same. So that means that these circles are the exact same size. So I can say UV is congruent with YZ because my measures are the same and my circles are the same size. And then we're not going to do any example problems with this. This last one, if you want to look at the proof, you can. But it just says that all circles are similar. So we've already talked about congruent circles. You know, they have to have the same radius in order to be the same size. But think about similarity. Similarity is same shape. All circles are the exact same shape, right? It doesn't matter. They just grow in size depending on their radius. So the statement can be made that all circles are similar. Okay? It doesn't matter what circle I have. A circle is always similar with any other circle.